Okay, so we always start out so silently. We just should do a little introduction. Hello, all you worldwide people that are watching. Welcome to Math 221C. This is lesson 22. So glad you could join us. Yay, hooray. 2 weeks to go.
And I graduate.
Yay, Eloise is going to graduate.
Woo! I'm tired. Yeah, it's been a long 4 years.
Sure it has. It's been a long 20 for me.
Way to rub it in. I have nothing to say to you. I'm just kidding.
Good.
Okay, so number 3, given the linear equation, y equals 2.0 plus 1.5 x, what is the y-intercept? Round to 1 decimal. So the y-intercept in this case is the first number, which represents b naught. Just learned that today. I guess we need to put in the 0. Both.
Mm-hmm.
Very good. Actually, these problems, I like.
Because it looks like algebra.
Yeah, I know. I'm like, okay, I can do algebra.
Yeah, it definitely, you can see the, it seems like
Makes sense.
somewhat logical until you start describing why the x or the y-intercept is not, no, I can't remember what they said. You can describe why the y-intercept, or you can describe the x, but you can't describe the y. Do you know what I'm talking about?
Oh, yeah.
Yeah, that's a little bit weird. Okay, so
3.0.
What?
For 3.
Oh, yeah, I put in 0.0.
2.0. It says round to 1 decimal, so 0 is a decimal place, I guess.
Yay!
Okay, number 4.
1.5. Wait, sorry, no. Yes, it is. Sorry, I looked at the wrong thing. 1.5.
Okay, so what is the slope in this case?
So if you go back to algebra, you realize that it's just the same way. It's like y equals mx plus b. The 2.0 would be the y-intercept, and the number that's next to the x would be the slope and the slope. Right?
Yep. Okay, I already did 5.
It's been too long. It's been too long for me.
5 is 1.
Okay, so, did you add it? Did you?
Yeah, I multiplied the 16. Like that.
Okay, let me. Did you guys try this in the SPSS?
With the data they gave us?
Yeah, when you do it, did you try finding the answer that way?
Yeah.
Yeah, I actually managed to make it work, but I didn't really think it was much faster.
Yeah.
I guess it probably depends on the equation and what if you already have the data set in there or whatever. Otherwise, it just takes up too much time. Faster do it on the calculator.
Yep. I agree. Okay, let's if I agree for the next one, I have to Are we all good with number 5?
Hold on, I did a error.
I got 7.
What?
Is that way off? Let me try it again.
Negative? Did you negative 3?
Oh, nope. Missed it.
1.
There you go, my dear.
That negative is too tiny.
It was really small.
Hey, this quiz is only 14 questions.
Hey. Okay.
Okay, what number are we on?
6.
6.
Oh, wow. Those are official shapes, huh? Interesting.
Yep.
Okay, what are we doing with
Math efficacy.
how about which one's the Y and the X?
Sorry, I'm. So when we're just doing a scatter plot like this, we can just look up the scatter plot. We don't have to worry about putting in like doing the analyze or anything. This information's
Yeah.
already there, right?
We do.
But we still have to do the X and Y axis, right?
Don't you have to add the tread line?
Probably, but first we're just getting the.
So the instruction says create a scatter plot in SPSS. Double click on the scatter plot. This opens the chart editor. Choose a menu option, elements, fit line at total. Choose the chart editor.
Which one did you do?
I did.
It's a hot dog shape.
What?
What?
What did you do for X and Y?
As an X, just, let's see. X is 1.5, no, sorry, I'm looking 0.25 times 16.
No, she's talking about for the scatter plot. What's the X axis and what's the Y? What did you put for the X or Y axis?
That's a great question. Let me look.
That we memorized first?
So would it be gender? Is on the X?
I would think so.
What was it called now? Oh, okay. I got it. Wait.
I think it's gender on the X and the score on the Y. Wouldn't that be right?
I think so. At least it's,
Because the score would change. The gender would not change, but the score would change.
yeah.
Oh, well, never mind. It doesn't like that.
It says the position on the horizontal x-axis represents the student's confidence rating, and the y-axis represents the score. So X is student's confidence rating, and Y is score.
Oh, okay.
I just read it in the book.
I'll take your word for it.
Okay. Or that is shaped like. What are our options?
Hot dog, hamburger, or banana?
Hot dog.
I guess so. I think we can rule out banana, but
Oh, so funny.
I really don't know what a hamburger shape would look like. Kind of ridiculous.
Hot dog, and there, that's
It's a half-eaten hot dog, I guess.
Oh yeah, on page 9, page 9 of our unit 21. I think it looks like a hot dog.
I think so too.
Okay. Let's go with hot dog. I mean, it stretches across the whole thing, so there is data
Yeah.
across the whole thing. Okay, based on the shape of the scatter plot you produced in question 6, what can you say about the appropriateness of using simple linear regression to model these data? I don't think we could.
Well, let me see what it says. The hot dog shape. Conduct regression analysis to determine if there is a significant linear relationship. For instance, hamburger linear regression is not appropriate, and banana linear regression is not appropriate. So it would be appropriate, right?
I think so.
So you're reading that hot dog shape is appropriate?
Yeah.
Yes.
Because there's enough of a line?
Yeah, it says decision. Conduct regression analysis to determine if there is a significant linear relationship. That's when there's the hot dog.
Well, I wonder if you can test it by trying to make a line. You know what I mean?
Yeah.
I want to try it.
Okay. Sure we can. It does. It makes a line.
Line.
Okay. So the third one then.
Sorry, my computer keeps cutting out. I think I have too many windows open, too many pages open. So we're going with simple linear regression is appropriate for these data.
Yeah.
Okay.
How many observations are in this?
So how do we find the observations?
Well, unless it says it somewhere else. See, if you scroll down to the bottom, it says 139. But, oh yeah, it starts at number 1, ends at 139. That.
Okay. I don't know.
I don't either. I've never had that question before.
I'm gonna put it in the linear regression thing and see what it says. So the dependent variable would be student competence, right? The independent would be no. Would be this. Or no. Just a minute.
Okay.
I don't know what I'm doing.
That's the club we're in.
I don't know what kind of question that is.
isn't it just how many there are? We're still on 8, right?
Yeah?
Yeah.
Okay. So wouldn't it be 139? It would be just the amount.
Well, that's what I would think.
That makes sense to me.
I guess I just feel like it's shitty feet.
So I looked up in our, yeah, I feel like I looked it up in our book and it doesn't have anything about legitimate observation, so that's what would make sense to me.
Well, maybe it would show on the scatter plot like how many. Wouldn't that be useful information to have on a scatter plot? How many points there are?
You'd think.
Okay. What did you say it was? 139?
Mm-hmm.
Yeah, if you go down to the bottom of the data set.
Okay. I just put it in the thing with the analyze whatever and it says 139, so
Oh, okay.
I'm sure you're right.
Let's hope so.
Alright. We're almost done. What is the y-intercept? Security is the confidence data with a constant variable and score data of the response. I think this is what I just did. Okay. So,
So wouldn't gender be independent?
yeah, so the dependent variable is confidence.
So confidence rating is the dependent variable.
Mm-hmm.
And then the gender is the independent?
Yeah.
Yeah.
No, it says you can't do it.
Which one was the score?
I did it.
You put gender in the independent box?
Yeah.
Mine comes up and says it's not allowed.
I put, okay, so no. The independent box would be the student's confidence. The dependent box would be the score.
Okay, so confidence rating goes in the independent box.
Yes.
And the score is the dependent.
Yes. Okay. Get it?
Yeah. So I have 18.690.
What? Oh, so. Are you looking at,
Wait a minute, what's it asking us? I thought it was asking for the...
so I think we look at under B, right?
Yeah.
So I have 1.296.
Really?
What did you get?
1.296. Did you click the little extra box? Now there's like a... Did you do correlate? Did regression, then did you do correlate? Or did you just...
No, I didn't. Let me check.
Thought we were supposed to do regression and then linear.
Yeah. But aren't we looking under... Is that what your B says? Because we should be looking under coefficients, and that should say unstandardized coefficients. Right?
Mm-hmm.
So,
And we're still using the math. Did we open a different thing?
no?
We're still using the math efficacy
Yeah.
data set, right?
Yeah. So, I did the regression first, the linear regression, and then I did correlate. You do the, whatever that is, for the variate,
Right.
and then when you did the variate, did you put both variables in the box?
Doesn't look like I did. You have to click on anything else, or you just click OK?
Okay, you put both variables in there.
Yeah.
Then did you click options?
Oh, you want? Okay.
Click
And it's
options.
means.
Yeah. And then you
Okay.
change. Okay.
Now I got so many windows open.
Did it work?
Well, my under coefficients, I'm still getting the same.
What did you get?
I got 18.690 was the,
The Y? That's what I had.
yeah.
But I was wrong.
Well, those were all coming up negative in the examples, right?
Christy's face.
Let me try it again. Let me bring it up again.
Did you get for the slope 12.695 as well?
Yes, I did.
Okay.
I did. Okay. Okay, so we're doing regression, right? Linear.
Mm-hmm.
The dependent variable is the confidence rating. Right?
Correct.
So say that again.
The dependent variable is the confidence rating. independent.
Yeah, if that's what you told me before, that's what I did.
Okay, so the independent variable is the score. So I press OK. Okay, and then I got the same thing. Okay, did you guys do the correlate or not?
I don't think you have to get the to get that coefficients box. I think you just say okay and it'll bring it up.
Mm-hmm.
Okay, I'm gonna start all over. Sorry. Okay, what is it called? Here, math up. Okay, I'm gonna try this one more time, and if I get the same answer, there's a problem.
Good luck.
Because all the rest of my answers are gonna be wrong if I go opposite. Okay. Regression, linear.
What the?
Dependent.
Weird.
Independent. Student confidence. Right? Dependent is the score, right?
Wait, what?
Okay. Independent is the student's confidence rating, right? Dependent is the score.
I hope Renee's listening.
Well, I'm not looking. I'd have to start over too. I'm not looking at it. If that's what you told me to do, I put in the ones that you told me to, Christy. So.
Okay, I just got the right thing because I put in the opposite of what I told you to put in.
Oops.
Yeah, so I got 18.690.
Wait.
What? We're right?
I had to figure it out for myself. I didn't not believe you. I had to figure out what I was doing.
Well, you had it right all along. Because you told me to do it the right way.
I know. I just put them in the wrong way. I said the right thing and I put them in the wrong way.
Such is life in statistics.
Yeah. Okay. So are you guys already done?
Okay, so we're going with 18.690, right?
Yes.
And 12.695.
Correct. So now our x equals 4.
Okay. All right.
And I got 69.47.
Okay.
Correct.
I believe you. I'm not there yet.
Okay.
Okay, let me just really quick. 18. 69.47, is that what you said?
Yep.
Great.
Okay, so what's the largest predicted? So number 12, the confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value for y for these values of x? So because there's a positive correlation, that means they're both going to go up. We can use the largest x value to find the largest predicted value of y. So is the largest x a 6? It says 1 to 6, so.
I don't.
I don't get it. What they're asking.
So we have to find the value of y. Wait,
The
what? What was the question again?
If we have the largest, I'm just looking to see if there's anything larger than 6.
Oh, so this is the one where we have to put it back into the data sheet?
I think so.
Right?
We could try that. So 6, wouldn't 6 be the largest? Because it's
Yeah. I think so. I mean, if 6 is the largest out of 1 to 6.
Okay, so we put a 6 in there. Okay, and then we go to what? I don't remember. Type the value.
Wouldn't it just be the y value times 6?
I don't know.
Or the, whatever it's called, the,
I've been doing this in MTSS. It's the same thing. And then you can press save. Standardized.
I don't think so.
What?
Oh, with the not like to yours too. So I don't think it would be the y value times 6 because our y value would be
I mean like the y-intercept or the slope times 6.
confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y? These values of x. Your answer should be exact.
I think you have to put.
Do you think we have to do every single one?
No, just if it was at the highest. 6 is the highest, so we just have to find what would y be. If x was the highest, we just have to find what y would be at the highest.
So it would be the slope times
6.
Yeah.
Right?
Y equals mx plus b. So it would be the slope plus the y-intercept. So it wouldn't it be
12.695 times 6?
So aren't we supposed to put this in?
Plus 18,690?
But that's the number we just got for the. No, this
Is that the number that...
This is the this has to do with the correlation. Like I'm reading from the lesson. It says, for example, in the correlation between the number of powerboats and the number of manatee deaths, the number of deaths is affected by the number of powerboats, but not the other way around. So we would assign X to represent the number of powerboats and Y to represent the number of manatee deaths. So when the confidence rating, if that's at the highest, then the Y would go up as many as that. I'm not explaining this very well, but
What I did? Okay, I got 94.85900.
I got 94.86.
Okay, well that rounded up.
what are you doing? How are you getting that number?
I
Okay,
did it through basic math. Sorry. I used algebra.
Oh, I used the SPSS.
Okay. What did you do?
Okay,
put in
I went
6?
in, what?
Did you put in 6?
Yeah, I put in 6 on the data sheet all the way at the bottom.
Okay.
Rating, okay. Then you go into analyze.
Okay.
regression,
Okay.
linear.
Linear. And then you just do the save thing.
You do save, yeah.
Okay. Got that.
Click unstandardized. And then click continue.
Okay.
And then go back to your data sheet and scroll all the way over to where it says 3.1.
Okay. Yep. So it did say in the lesson that if you do it in the calculator, you do it in SPSS, you're going to come up with different numbers.
Yeah, so in SPSS, I got 94.859, so Chrissy's number's correct.
Okay, so we need to round this or what?
No, it has to be exact.
So we're putting all those zeros in too?
No, I just... Really? You want to put all the zeros?
I don't know. It said exact.
Yeah, what do they mean? You want exact, let's... We're going to put somebody on the moon, we better be exact. Or they're going to end up somewhere else.
Oh,
Okay. How many zeros again?
There was 2, yes. Hopefully the computer knows about zeros.
yeah, hopefully. Okay. How many explanatory independent variables are present in simple linear regression?
Isn't there just one?
I don't know. Well, is it independent and dependent?
I can't hear you, Chrissy.
Is it independent and dependent? Would that be?
I
I don't know.
I don't really remember them talking about that too much.
Well, we only put one and one on each on our.
For the simple, you can have more than one variable. They did talk about that, but to have simple linear, I don't think you can.
Yeah,
Okay, I'm gonna look it up.
I don't know. I don't remember being asked that question. Alright.
Okay, this says simple linear regression provides a tool for data involving 2 variables, the independent variable and the dependent variable.
So one each then?
But this says, oh, how many explanatory independent zones is there?
Yeah,
Just two. Okay.
so one of each.
Right? It's a little confusing. But whatever.
Oh, it says.
So how many responses? Only one, right?
Yeah, it's just one because it said if there was more than one, it would be called multiple. All right, people.
So they're both 1, right?
Yep.
One independent and 1 dependent.
Yep.
Okay, let's go through the answers really quick because last time I pulled Vanilla Lisa and this one. Funny.
that was sheer like frustration. I think your brain was just done.
Okay, so we have 3 is 2.0, right?
2.0?
Yes.
Yeah.
4 is 1.5.
Yep.
5 is 1.0. 6 is a hot dog. 7, simple linear regression is appropriate for these data.
Mm-hmm.
8, 139.
Yep.
9, 18.690.
Yes.
Did you say 19 or 18?
18.
Okay. Phew.
Okay. 10, 12.695.
Yep. Yes, that's what I have.
11, 69.47.
Okay.
12, 94.85900.
Okay.
And 13 and 14 are both 1.
Okay.
Okay. I'll wait.